Hey kids, Flexing Teacher Weber here. Hope you had a good weekend. So we have been studying area. Last week I had you work on area of a rectangle and area of composite figures made from rectangles. Now, here is a rectangle. Okay, and we know from last week that a rectangle, the long side we normally refer to as the length, and the short side we normally refer to as the width. And the opposite sides are the same length, so this side and this side are the same, and this side and this side are the same. And last week we learned, well, you probably learned in grade 6 as well, that the area of a rectangle is equal to the length times the width. Now, we're going to start studying parallelograms today. This is a parallelogram. Okay, a parallelogram has its opposite sides parallel. Okay, which means they run in the same direction. Now, the goal today is to sort of discover why the math equation for the area of a parallelogram is basically the same as the math equation for the area of a rectangle. So rectangle, parallelogram. What I'm going to do is I'm going to make this rectangle into a parallelogram. So I'm going to make this parallelogram go away. Bye-bye parallelogram. But I'm going to magically turn this rectangle into a parallelogram. Addison, may I have a pair of scissors, please? Thank you. Very well done. Thank you. Well done. That's my assistant, Addison. Now, what I'm going to do first is I'm going to cut this rectangle from one diagonal to the other diagonal, from one corner to the other corner down the diagonal. Okay? So I'm going to try to make this as straight as I can. All I'm asking for is total perfection. Okay. So, oh no, rectangle down. Okay, I'll pick up that guy. So, what we had here is we had, no we didn't, there we go. We had a rectangle, and I cut that rectangle down the diagonal. Okay? Now watch what I'm going to do. Okay? It's going to be some math-magic now. I have to remember how to do it, because I'm having a little bit of, I'm forgetting for a second, but it just takes me a second to remember. Okay, so I've cut down the diagonal, and now I'm going to do this. And what we have here, you can see that, I have now made that guy into a parallelogram. And I haven't changed the amount of area that's there, so I'll even turn it like this. Now there we have a parallelogram. I haven't changed the amount of area there. It's still the exact same area as a rectangle. Now what I'm going to do is I'm going to tape this together so I can, actually I don't need to because I already have another one. There we go. So here's my parallelogram that I constructed by cutting the rectangle. Now if you take a look, the rectangle and the parallelogram have the exact same amount of area. Now the math equation for area of a rectangle is area equals length times width, and it's basically the same as the area of a parallelogram, except in a parallelogram we call it the base times the height. Now the base of the parallelogram is the bottom. The bottom right there, we call that the base. And the height is going to be the straight up and down distance. So one of these guys is not going to be the height because it's going like in a diagonal direction. So we actually measure the height straight up and down from the base. And we say the area of a parallelogram is base times height. And the area of a parallelogram is exactly the same as the area of a rectangle. Now in my next videos I'm going to actually go through the math equation with you and show you how we identify the base times the height. But just to review, we started off with a rectangle, we cut it down the diagonal, and it was like a transformer almost, the most boring transformer in the history of humankind. It transforms from a rectangle, oh that's not the way, it transforms from a rectangle into a parallelogram, and we don't lose any of the area. So the math equation for area of a parallelogram is basically the same as area of a rectangle, and we will see that in the next video. Flexing teacher, oh, one more thing. Okay, before I go, Addison, can I have that? So my daughter Addison, there we go. My daughter Addison has created a math question for you to solve as well. So if you want to solve this question, you can as well. Okay? Flexing teacher Weber, out.